we're going to use these definitions of continuity. We're going to use the definitions of the intermediate value theorem, definitions of continuity, and continuous. Use these things. All right. So the first kind of question. Let's just review. Review about limits. Two important definitions we need, right? The definition of continuity. Continuity was 3 parts, right? Three parts. 3-part definition of continuity. There were 3 requirements. The first was that the limit, as x approaches some value of an equation, exists. The limit has to exist. Meaning it's not D and E or a discontinuity. Right? Second important definition of continuity is that f of c exists. Right? It's not infinity or a whole or some other weird thing like that. The function has to exist at a point. 3 parts, right? The limit exists at that point. The function exists at that point. And what was the third part, everybody? The third part, for the definition of continuity, what's required? Say it out loud or type it in the chat. What is the third requirement for continuity? The limit has to exist. The function has to exist. And what's the third part? Anybody remember? Check back in your notes. Paris, I think you were talking about f of c equals. I couldn't hear, your audio was a little bad. Lizette, yes, exactly. Not minus, but equals. The 2 things that exist, the limit of the function and the value, have to equal. Yes, that is exactly. Oops, that's a C. That is the definition of continuity. So the limit has to exist, the function has to exist, and the limit and the function have to equal each other at that point. That's our formal definition. And again, if one of these is missing, the function is not continuous. And we state that explicitly. You can't just say, oh, it's not continuous because there's a hole. That would not be an acceptable answer. You have to be explicit. Which one of these is broken? How does it work, right? So that's for continuity. We also had definition of continuity. What else did we have? Let me look at my notes here. Continuity, definition of continuity. We also had the intermediate value theorem. We talked about the intermediate value theorem. That was also 3 parts. The intermediate value theorem was we had to test 3 things. First, the function f of x must be continuous. To satisfy the intermediate value theorem, that's the thing where you're like between, right? Betweenness, intermediate. So you hear this word intermediate, think of betweenness. You look at a problem that's asking you to find things that are between stuff. You need to make sure, the first definition, you need to make sure that the function is continuous. That's your first step. After that, you check the y's. Check that the y is between, right? I should say continuous on an interval a to b. check that y is between the low f of a and f of b. And 3, you state that state that there is a c. There is a c between a and b, where f of c equals, well, whatever, we call it k, right? Check that k is between f of a and f, right? There's some value, some y value, right? That k value. State that there is a c between a to b, where f of c equals k. That's our intermediate value theorem. Check that it's continuous. Check that you're between the a and b. Once you have all that, you can state that there is a value. And then sometimes, to find c, you plug in the k and solve. So you'll get k equals blah, 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 some function, x squared plus 2x minus 3, whatever, right? Solve for x. Sometimes they have you find the c value. You plug in your equation. Once you have your value, you plug that in, and you solve for the x's. Sometimes you have to factor. Sometimes you have to do square roots, right? We did a little bit of that. Okay. So these two definitions are critical to know. The definition of continuity and the intermediate value theorem. Everything that we do with limits sort of depends on these two definitions. Not everything, but a good deal. So I want to do a little bit of odds and ends. I'm going to show you an example of a question from an old AP test and show you kind of what types of questions you can have, what types of questions they'll give you, and then and we'll go from there. So let's see, how can I do this? Can I take this? Which page is this? Here, page 7. Can I take this and drop it in here? Is this going to work? Let me see if one. Did that work? That didn't work. All right, hold on. Hold on, let me go like this. Go like this. You I don't need anymore. Oh, shoot. No, I needed that one. Oh, God, everybody. I don't need you. I don't need you. I don't need you. Should have done this before. Hold on. Okay, here we go. So, an example from a previous AP test. Down here. This is a free response question, so this is a question that they required you to write your answers for. And in these free response questions, they want you to write things explicitly. So we're going to do this together and figure out how to solve this question using limits and using our our knowledge of continuity. So read this question. Example 10 question here. We have a table of values. We have some x values. We have some function f, and we have some function g. Some function x, some function x, some function g, f and g. And before you even start, you should just take a look at this graph and try to understand it. Okay, our x values go from 1 to 4. So, like if you're picturing the graph, you don't need to draw it, but if you are picturing the graph, know we're like on these 1, 2, 3, 4 values. Look at what f is doing. F goes from 6 up to 10 down to -1. So f kind of goes like up and then down. Just get a picture in your mind of what it's doing. Kind of goes up and then down. G, 2, 3, 4, 6, G kind of just goes up. All right, so G goes up. We have this 1, 2, 3, 4 values, F and G. In the question it says, The functions f and g are continuous. This is not just something they throw out there for fun. This is important. They are telling you they're continuous for a reason. They're telling you, they don't just say things casually in the AP test. The information they give you, every word, is juicy with meaning. Juicy word here, continuous. F and G are continuous functions for all real numbers. That means that we can use things like the intermediate value theorem. We know they're continuous. We don't need to worry about them. So we know they're continuous. The table gives some values for the functions as a selected value of x. That's fine. So it's not only continuous here, it's continuous everywhere. And then we introduce this new function h, which is f of g minus 6. F of g of x minus 6. So this is a function composition. Remember we talked about the composition of functions in pre-calc. This is a composition. So you're going to plug into g, and the answer you get for g, you plug into f. So it's like a double function. H is this double function, and then minus 6. And the question says, explain why there must be a value r between 1 to 3 such that h of r equals negative 5. Explain why there must be a value r between 1 to 3 such that h of r equals negative 5. So this question, it gives us an interval, it gives us a value. We're looking for a value on an interval. This is the kind of question that uses the intermediate value theorem. These are the kind of questions you need to recognize as intermediate value theorem questions. Juicy information, continuous. We got a value, right? This word value here. Between the interval here, right? There's a value, here's an interval. And here's a value, right? We're looking for a value of r where we have a y value. So this is the intermediate interval value theorem. These are the clues that give you information about knowing that you're using the intermediate value theorem. So what are our methods? How do we explain why there must be a value? Right? We have three parts. First, is it continuous? What do you think, everybody? Is h continuous? Now, why do we say yes, Lizette? We think yes, and it's probably true, but how do we know for sure? What is h? H is this composition equation. H is this, right? H is composition. It does, yes, exactly. H is continuous because, yes, because composition is continuous. Composition is continuous. Continuous. And F and G are continuous. It's important to state that composition is continuous because H is a composition function. And when you compose functions, you don't change their continuity. The only time continuity changes is when you do division. Division is the real big killer. If we had a function f over g, right? If h was some division of f divided by g, then we could say it might not be continuous, when g of x equals 0. Right, so this would be a problem. It's only continuity, or Our functions being continuous are only a problem when you do division. Division is the killer. If we're not doing any division and our functions are continuous, we're going to be continuous. So we need to state, explain, right? Explain why. And the reason why is because h is continuous. That's number one. Number two, we need to check -5. Check that -5 is between h of the low and h of the high. We need to check that h is between our two values. Check that -5. Right, we're looking for this -5 value. We're looking to see that -5 is between the values. So we need to know, is there a negative, like does -5 land between my low and my high of h? And this is my A, and this is my B. So I'm going to plug in h of 1, and I'm going to plug in h of 3. And you just have to do the calculations for this. There's no simple way. You just got to show what is h of 1, what is h of 3. H of 1 is f of g of 1 minus 6. So what is that? F of g of 1. Well, we look for g of 1 first. G of 1, here's 1, here's g of 1 is 2. So this is going to be f of 2 minus 6. Composition, everybody. F of 2 minus 6. So what's f of 2? Here's 2. Here's f of 2 is 9. So this becomes 9 minus 6, which is 3. So on one side I have 3. This 2, yeah, absolutely, this 2 came from g of 1. So here's where x is, here's where x is 1, right? Here's where x is 1. And g of 1 is 2. Right, if you plug into g, if you plug in the 1, this is how you read the table, right? When you plug in a 1 into g, you get a 2. So that's what this table is saying. G of 1 was 2. And then we took the 2 and we plugged the 2 into f. Here's x is 2. Plug that 2 into f, we get a 9. Okay? So we need to use this composition. We need to use h and just plug in the values. And this extra table thing, they do this a lot. They like to do this problem. Where they give you this table with two functions. They give you some crazy composition. And you need to use the intermediate value theorem, show the low and the high, plug in the h boundaries, and then from those boundaries, you see if -5 is between them. All right, so now let's do the h of 3. Same thing, h of 3. I'm going to do that up here. H of 3 is f of g of 3 minus 6. So I'll do yellow for these. So g of 3, here's 3. G of 3 is 4. So g of 3 is 4. So I'm looking for f of 4. Right? Minus 6. Do that in blue. F of 4. Yeah, because the g of 3, I plug in the 3 to g, G of 3 is 4. And now I'm looking for f of 4. F of 4, let's do this in red, sure. Here's 4. F of 4 is negative 1. So f of 4 is negative 1. So I've got negative 1 minus 6, which is negative 7. So the low side is negative 7. From 3 to negative 7. So that's my low and my high of the y's. That's the y's. Is everybody okay with what we just did here? Thumbs up. Please give me the thumbs up emoji if you're okay. Please give me the, I don't know, what other emojis are there? Sad emoji if you're bad. Things are... All right. People look like they're okay. Good so far. So here's the question. Is negative 5 between my low and my high? Yeah, right? Between 3 and negative 7. Negative 5 is located between 3 and negative 7. So we're good with that. We checked our boundaries. We found that it was between it. So now we have to state, our proof, right? Our explanation. Say, yes, there is an R between 1 to 3 where h of r equals negative 5 because h is continuous on 1 to 3 and negative 5 is between, you could say this to it, f of a comma f of b or 3 comma negative 7. This would be your statement. Something like that. But you need these specific pieces. You need to state these three things. You need to state that it is continuous on the interval or everywhere. You need that. H is continuous. And you need to say that negative 5 is between f of a and f of b or 3 to 7. You need that. Without those two pieces, you will not get any points. And you need to say this, that there is an R between those two numbers. Three pieces you need in this proof. You could state, and you can do these kind of in any order. It doesn't really matter the specific order as long as you have all three pieces. Yes, because h is continuous and negative 5 is between these, there exists an R between 1 and 3. Or because negative 5 is between these two values and h is continuous, the order it's not really critical. The order is not really critical. But you need all three pieces. Okay. Questions about that? People okay? So that's a little odd and end, one of the little odds and ends that I want to show you. Another one, let's do another one here. Let's talk about some real life situations. And again, stop me if you have a question. Let's talk about a real life situation here. Let's see how limits can influence what we want. For example, if you have, let's say, a rock is thrown off a cliff and follows or I should say follows the table below. So let's say we have a rock that's thrown off a cliff. Its x values and its height of x. All right, not x. Let me say t, because this is time. Time at 0 seconds, at 1 second, at 2 seconds, at 3 seconds. Okay, and its height, let's say, is 123 feet. This is in feet. Not feet. And this is in seconds. 123 feet. We have let's say we have 109 feet. We've got 87 feet. We've got 52 feet, and then 4 seconds we're at 30 feet. 5 seconds we're at 5 feet. 5 feet above the ground. Okay, so this is some information about the height of a rock that we threw off a cliff. Okay, given some information about a table. Okay. So I want to justify. They will sometimes use the word justify, same thing as explain. Why there must be a time t equals c where the rock is 90 feet high. Why must there be a time t equals 6, or t equals c, sorry, t equals c, some time, t equals c, I should say between 0 to 5, where the rock is 90 feet high. So this question, again, we're looking for an interval. We have an interval, looking for a value on an interval. This is another IVT problem. So the first thing we need to do is show that it's continuous. Is h of t continuous? What do we think? Do we think that this function is continuous? Is the function continuous? Right after time. Why there must be a time. Oh, t equals c. T equals c. Where the where the rock, goodness gracious, where the rock is 90 feet high. Why there must be a time t equals c where the rock is 90 feet high. time t between 0 to 5. Time t equals c between 0 to 5. And so we're looking for a value between, we know the intermediate value theorem. First of all, is h of t continuous? This is the question. Is this function continuous? What do you think, everybody? Does it tell us it's continuous anywhere? Do we see that it says the h function is continuous anywhere? Does it state? I don't see it saying continuity anywhere. I don't see it talking about continuity. How can we be sure? Is h continuous? How do we know? What do people think? Yes, h is continuous. No, h is not. How do we know? Any ideas, everybody? Yeah, not only hit the bottom. I mean, like, yeah. Well, think of it logically. This rock, this measurement, this thing we're talking about is a physical action. It's a physical situation, and a rock, when it's thrown, it follows a continuous path, right? The rock is not going to disappear from one spot and reappear somewhere else, skipping a bunch of stuff. Because this is a physical scenario, we can be sure that h is continuous. So sometimes you need to kind of be aware of that. Sometimes you think you would need to justify it by saying, yes, because h of x represents, you could say, a physical situation, a physical scenario that is continuous. So sometimes it doesn't tell you it's continuous, but it tells you about a situation, and logically you know it's continuous. Physical scenarios, like time doesn't skip around, the rock doesn't jump from place to place. It's a continuous scenario, just logically, and you can say that. That's okay. Sometimes they do those kinds of justifications. So we know it's continuous, right? So then we can use the rest of the intermediate value theorem to figure it out. But here's another question. Question 2. Find, in this scenario, find the limit as x approaches 2 of h of t. And then justify your answer. So again, we have our situation where our height of a rock is flying through the air. I want you to tell me what is the limit as x approaches 2 of this function h. What's the limit as h approaches 2 of this function? If you had to guess, everybody, what do you think the answer is to this limit as x approaches 2? I should say t. T approaches 2. T approaches 2. What do you think the limit's going to equal? What number do you think the limit's going to equal? Look at the table. What number are we going to equal as t approaches 2? Yeah, it's going to be here. It's actually 87, not 8.7, but my numbers are a little off. Yeah, 87. Clearly, the answer is 87. That's where the rock is going, right? We know the rock is moving. It's flying through the air. It's going to equal 87. But how can we be sure? How can we justify the limit as t approaches 2 of h of t equals 87? Because why? Because why? What possible reasons can we give? I mean, could we just say, like, because... can we say because... duh? I mean, look at it. Is that good enough? No, not going to work. And this is where you really need to understand the definition of continuity. You really need to understand what limits and values, how limits and values are connected. We know the limit is equal to 87 because we know that h of 2 is equal to 87. But how do I connect this value with a limit? How do I connect these two? And the thing that connects these two is the definition of continuity. The thing that connects the value of plugging in that you get in the table and the limit that you find as it approaches a value, the thing that connects those two is the definition of continuity. And the definition of continuity says that if it's continuous, then the limit is equal to the value. Right? That was our definition of continuity. If something is continuous, then we are for sure all of the values of the equation are equal to the limits of the equation. All of the limits and all of the values match. For sure, if it's continuous. For sure. That's by definition. That's the definition of continuity. The value and the limits are connected. And so the way we would justify this, is we'd say, because h of t is continuous for all t, let's say all real values, real t values, or you could say on an interval, whatever you want. The definition of continuity states that for all values, the limit as t approaches some c value of h of t equals the value h of c. So the limit as t approaches 2 of h of t equals h of 2, which equals 87. And that's what you would write. And that's a justification. If this was a free response question on the AP test, this is what they would like you to write. because h of t is continuous for all real values or for some interval, right? The definition of continuity states that for all values, the limit equals the value. So the limit as t approaches 2 of h of t equals h of 2, which equals 87. The limit equals 87. And so we can be sure that that's true, because we use the definition of continuity to make it sure. Okay? Questions about that? So yes, so this says the limit as t approaches 2 of h of t equals h of 2, which is equal to 87. Sorry, hold on. Thing's acting up again. So yes, the limit as h approaches 2 of h of t, that's h of t equals h of 2. Because remember, the c value that you are looking for, right, the c value you're looking for, equals the plugging in that c value over here. All right? All right, what are the little odds and ends can I show you? Any other questions here? So if you're trying to find a limit, and you have a value, or like a table, to connect those two, it's the definition of continuity. That's how you connect values to limits. You connect the value and the limit through the definition of continuity. All right, let's see. What else can I... There we go. What else can I... what other little odds and ends are there? Right. Let's see. So another thing we talked about was, oh right, piecewise functions. So occasionally, another question they will ask you occasionally, we didn't cover this before, we'll end here, is, oh, come on now. Oh, thing is piecewise functions. Let's talk about piecewise function. Wise functions. They love to use these. And what I'm going to do with these piecewise functions, I'm going to make them continuous. Make them continuous. So if I have a piecewise function f of x, and I say that this equation is x plus 3 when x is greater than 5, and I have a when x is less than or equal to 5. My question is, what value of a, makes f continuous? What value of a makes f of x continuous? So really what you're doing, and this is a right here. This is, I mean, make it a little better. This is a. Really what you're doing is you're trying to make the sides match at some value of x on the edge. You're trying to make the two sides match at the value that is the edge value. So for us, we're trying to make the sides match at some value of the edge. So my edge value is 5. This is my edge, right? That's where the two graphs kind of split apart, where the changeover happens, where the handoff happens. And I'm trying to make the handoff match. So what you're going to do, really easy, is you plug in x and make the equations equal and solve for a. So in this case, we have one side is x plus 3, and the other side is just a. And I'm going to plug in my 5 into this equation. Plug in my 5. Right? Let me just make this x again. Let's make this x. I'll show you explicitly. Right? That's x. I make the two sides equal each other. I plug in my 5 plus 3 has to equal a. And so that means that a has to equal 8. And if a was equal to 8, that would be the number that would make this graph continuous. That would make them match. Make them match. So the process is pretty straightforward. Looking for a value that would make them match. But they can get a little complicated with equations. So for example, if I said f of x was equal to another piecewise function, 2x squared minus 3, and let's call this ax plus 5, and I say that x is less than equal to 1 here, and x is greater than 1 here. Again, find a so f of x is continuous. Again, I'm gonna make this x a different number. I'm gonna make x into 2. Sorry, everybody. Make x into 2. So what I need to do is set my two sides equal 2x squared minus 3 equals ax plus 5, and then I plug in my 2. Plug in my 2 into all the x's. So this is 2 times 2 squared minus 3 equals a times 2 plus 5. And then I solve for a. This is 2 times 4 minus 3 equals 2a plus 5. That's 8 minus 3 is 5 equals 2a plus 5 minus 5 on both sides. 2a equals, 0, I guess. A equals 0. That's kind of a weird answer, but anyway, that's the idea. Plug them in, make a match. Maybe I should have stuck with 1. Oh well. But when you're faced with these questions, and you're asked to find a value to make the function continuous, what that means is you want to make them match. So you match them up, and you plug in the x value, and solve for the missing part. Sometimes you'll need to do solve, what's the word? a multi-equation, you'll have A's and B's. Maybe there'll be 3 parts, and you have A and B. You'll have to solve a system of equations. To rearrange, get A equals some number, then plug that A into the other thing. Systems of equations. Remember how to solve systems of equations. See if you can remember how to do those. But this is what you do. You set them equal, you plug in the x, and you get the a and the b, whatever else, by themselves. All right, one more little odd and end that was asked about. Sometimes equations will give for intervals. Let's talk about intervals. Intervals. Sometimes an interval has boundaries like this, a to b, and sometimes it has boundaries like this, a to b. Or sometimes it's a to b, or sometimes it's a to b. You have these parentheses and you have these brackets. I want to tell you about the difference between a bracket and a parenthesis on intervals. So brackets mean it equals the value. So, for example, if we're looking at a graph, right? Like here's A, here's B, right? You start somewhere, you do some interval, you end somewhere. A to B, right? You're actually located at those values. Parentheses means things like asymptotes, or holes. Parentheses means you don't actually reach the value. So let's say here's A and here's B. You could have a hole at A, travel along, and then maybe you have an asymptote at B. It's still an interval, it's just not a closed interval. We say this is a closed interval, and this we say is an open interval. And it does not change the problem with the intermediate value theorem. It doesn't change the intermediate value theorem. It just means, well, sometimes you'll have to do different things for A and B. But most of the time we're going to deal with these closed intervals. Most of the time it's going to be these. And not very often do we deal with open intervals. Not very often. But I know there were some questions about that. I wanted to clarify what the parentheses versus brackets mean. And there are lots of little examples, lots of little questions that we'll have using intermediate value theorem, using the definition of continuity. So I want to give you some practice. Your assignment, of course, first of all, make sure you finish the Edgenuity assignments. But your other homework is in the textbook, a review, AP practice questions, page, what is this, 99. Numbers 1 through, I think it's 16, all. AP practice questions. Page 99, numbers 1 to 16. Half of them are free response, half of them are multiple choice. Give those a try. It is due Friday. We will review it on Thursday. And we'll do our last review on Thursday because your Unit 1 test will be next week on Tuesday. So we'll have our last review on Thursday. Try these questions out. Do all the Edgenuity assignments. Practice some things on IXL and Khan Academy if you want. But give this a try, everybody. That's it for us today. Yep, type goodbye in the chat. Once you type goodbye, you're free to go. I will see you Thursday. Thank you, everybody.